So this is my tutoring video for Gen Chem 1. The topic we're going to be discussing is solubility. So a guiding question I want you to ask yourself throughout the course of this video is, how do I determine what's soluble and how do I determine what's not soluble? So briefly, solubility is determined by solubility rules, which it's important to note are hierarchical, which is why this is in a different color here. The hierarchy means that we have 6 solubility rules, as shown here, and Rule 1 is more important than Rule 2, which is more important than Rule 3, and Rule 4, and so forth and so forth. And what this means is that if I have contradictory information, which you'll see in an example here in a second, that's given between these solubility rules, it means that whatever contradictory information that's listed higher in the hierarchy of these solubility rules, again, the hierarchy is determined from 1 through 6, will take precedent and overrule whatever other contradictory information that's contradicting it that could be lower in the hierarchy. Let's do an example real quick just to make sense of this. So let's say we have AgNO3. This is silver nitrate. So the first step whenever you're solving one of these problems is to break up the ionic compound into its constituent components, which in this case would be the silver cation and the nitrate anion. Now let's go over to our solubility rules once we've done this and see where this lines up. So briefly, we're going to go over the solubility rules real quick. Group 1 and ammonium, this is not ammonia, ammonium is NH4+, are always going to be very soluble. Number 2 states that nitrates, acetates, and perchlorates are soluble. Number 3 states that salts of silver, lead, and mercury are going to be insoluble. Chlorides, bromides, iodides are going to be soluble. Carbonates, phosphates, sulfides have an exception here. Oxides, hydroxides are going to be insoluble. The exception with sulfides is that sulfides of calcium, barium, and strontium are going to be soluble. Sulfates are soluble, but again, those same weird alkali earth metals, those are our group 2 metals, of calcium, barium, and strontium are not going to be soluble. These 3 metals oftentimes contradict our solubility rules, and it's important to make note of those exceptions here. So, looking back at our example here, AgNO3, silver nitrate, we have our Ag+. We'll attack that first. We go through the rules, Okay, I found silver. Silver is a salt of Ag+, and I get that from Rule 3 that's going to be insoluble. So let me write that down real quick. Okay, it's going to be insoluble, at least this component is, and I get that from Rule 3. Let me make note of that because this will actually give us contradictory information when we look at the nitrate. The nitrate anion comes from Rule 2, and it says that nitrates, acetates, perchlorates are going to be soluble. So nitrates are going to be soluble here. So let's look at this. Okay, that comes from Rule 2. So I'm getting contradictory information here. I'm getting from these solubility rules again that the silver is going to be insoluble, but that the nitrate is going to be soluble. This is where that hierarchical understanding is going to come into play here, because I get that it's insoluble from Rule 3, but Rule 2 states, which is higher, I mean, it's not greater than Rule 3, so I understand how that might be confusing, but it's higher up than Rule 3, because Rule 1 is going to be the top, 2, 3, 4, and so forth. It says that it's going to be soluble. Therefore, AgNO3 is going to be soluble, which means it's going to break up into its ionic components when it dissolves in an aqueous solvent like water. Now, let's look at another example. Let's say we have iron 3 hydroxide. So the chemical formula for this would be FeOH3. Let's look at the rules. I get nothing for iron from these rules. Okay, not to worry. I didn't get anything from iron. We're just going to leave that blank. What does hydroxide say? I'm going, and oh! Hydroxides are insoluble, and there's no exception to it other than these rules up here. Well, I already determined that there's no exception here. Iron gives no exception. There's no rule above this hydroxide rule. That means nothing in rules 1, 2, 3, and 4 that says that iron will overrule hydroxide being insoluble. Therefore, hydroxides, based on Rule 5, are insoluble. And that means that this is going to remain a solid. It's not going to break up into its ionic components in an aqueous solvent I hope that this video is informative. Here are some questions that you can try for yourself to determine whether or not you understand this concept. These are lead acetate. And to give you a hint, to start off, we see that salts of lead are going to be insoluble, and that's rule 3. But acetates are rule 2, and that's going to be soluble. And silver chloride. Again, we find silver here and chloride here. That's going to tell us that if you solve this on your own, you'd find that this is going to be soluble, and this is going to also this is going to be insoluble, because the silver being insoluble is rule 3, and the chloride being soluble is rule 4. I hope you found this video informative. This is my Khan Academy styled video. Thank you.